So in this introduction, the periodic table, whatever we'll discuss now, it is a remarkable demonstration of the fact that the chemical elements are not a random cluster of entities, but instead display trends and lie together in families. And awareness of the periodic table is essential to anyone who wishes to discover the secrets of the world and see how it is built up from the fundamental building blocks of the chemistry, that means the chemical elements. So today's learning point is the historical development of the periodic table as it stands today and the modern periodic law. We know now that the elements are the basic units of all types of matter. In our previous class, in the chapter number 2, we explained in details. In the year 1800, only 31 elements are known that time, by the year 1800. But after 65 years later, in the year 1865, that number increased almost double to 63. And at present, we have the 118 elements we know so far, and out of these the 94 elements is naturally occurring and rest 24s are discovered by human beings. So effort to synthesize new elements, till now it is the continuing process, and with such a large number of elements, it is very difficult to study individually the chemistry of these elements and their innumerable compounds individually. So that's why we need to classify the elements. Then scientists searched for a systematic way to organize their knowledge by classifying the elements. And not only that, it would rationalize known chemical facts about elements, but even predict new ones for undertaking further study. Later we'll know that how Mendeleev predicts for the new elements in his famous periodic table at that time. And later that new element was discovered. We'll see it later in this class. Classification of elements in groups and development of periodic law. Periodic tables are the consequence of systematics by a number of scientists through their observation and experiments. In early 1800s was the first to consider the idea of trends among properties of elements. And that is considered as a starting point to make the elements as per their properties in different families. And after 29 years later, in the year 1829, he noted a similarity among the physical and chemical properties of several groups of 3 elements, and it is called the triads. In each case, he noticed that the middle element of each of the triads had an atomic weight about halfway between the atomic weight of the other 2. And the properties of the middle element are in between those of the other 2 members. This is called the triads, and that is the beginning to classify the elements as per their property. Bernoulli's relationship, which is referred to the law of the tirades, seems to work only for a few elements. And after that, this concept was dismissed. The next reported attempt to classify the elements was made by the French geologist A.E.B. de Chancautitos in the year 1862. So down you can see the left side table. This is the table as per the law of tirades. And here the elements lithium, sodium, potassium, calcium, strontium, barium, and chlorine, bromine, iodine. These elements was explained by the law of tirades. In this case, if you count the middle one, then you will see the middle one is almost average of the atomic weight of the first elements and the third elements. In this way, de Broglie explained in his law of tirades, which was dismissed during the development of further periodic classification. And as per the Chancautitos in the year 1862, he arranged the known elements in order of increasing atomic weights and made a cylindrical table of elements. In the right side figure, you can see this is a cylindrical table, and to display the periodic recurrence of properties. Here you can see that if this cylinder, if you see, then in this direction, that all the elements having the similar properties can be arranged. And here you see the hydrogen, lithium in this way, and another starts from the oxygen, and another elements is there. So this is the cylindrical table of elements to get the periodic recurrence of properties of the elements. And that is also, that time it was one attempt to classify the elements as per their properties. So another English chemist, John Alexander Newlands, in the year 1865, in his law, the law of octaves, he arranged the elements in increasing order of their atomic weight and noted that every 8th element had properties similar to the first element. In this table, you can see the atomic weight is increasing from element lithium to beryllium to boron, carbon, nitrogen, oxygen, and fluorine atom. And after that 8th element, again the same property has come for the first element. That means the property of lithium is similar to the property of the next 8th element, sodium, and in this way for potassium also has similar property like lithium and sodium, and so on. So this is the Newlands octaves. That means the law of octaves propounded by John Alexander Newlands in the year 1865. And in this relationship, what I already explained, it is mentioned there. You can check the written form of it. And the Newland's law of octave seems to be true only for elements up to calcium. See, this is in this table, as per the increasing order, the atomic weight, this is the last element is calcium. So up to calcium, this law of octaves is true. Although his idea was not widely accepted at the time, he, for his work, was later awarded Davy Medal Award in the year 1887 by the Royal Society, London. That history also we have to know for the development of the periodic classification of elements. The periodic law, as we know it today, it is related to the development of the Russian scientist Mendeleev and the German chemist Lothar Meyer. They worked independently, and what they proposed that the arranging elements in the increasing order of their atomic weights, similarities appears in physical and chemical properties at regular interval. So we'll explain more clearly on it in the next slide. Lothar Meyer plotted the physical properties such as the atomic volume, melting point, boiling point against the atomic weight and obtained a periodically repeated pattern. And in the year 1868, Meyer had developed a table of the elements that closely resembles the modern periodic table. However, his work was not published until after the work of the Mendeleev, the scientist who is generally credited with the development of the modern periodic table. And in this Mendeleev periodic law, what it states that the properties of the elements are a periodic function of their atomic weights. That is the statement, and this statement is considered as law to explain the properties of the elements as per the Mendeleev's periodic law. This is the Mendeleev's table, periodic table. That time it was published, because modern periodic table is little bit different from this. And in this table, if you see that there is some horizontals and verticals line in that table, and that means Mendeleev arranged the elements in the horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the elements with similar properties occupied the same vertical column or group. Mendeleev's system of classifying elements was more elaborate than that of Lothar Meyer's. Mendeleev fully recognized the significance of periodicity and used a broader range of physical and chemical properties to classify the elements. That means the Mendeleev relied on the similarities in the empirical formula and properties of the compounds formed by the elements. He realized that some of the elements did not fit in with his scheme of classification if the order of atomic weight was strictly followed. He ignored the order of the atomic weights, thinking that the atomic measurement might be incorrect, and placed the elements with similar properties together. So there are some examples that iodine with lower atomic weights Then that of the tellurium in the group number 6 was placed in group number 7 along with the fluorine, chlorine, bromine because of the similarities in properties. Why this one happened? Now we know that the periodicity depends on the atomic number, that means number of proton present in an element. So that is the modification from the Mendeleev's periodicity law. And Mendeleev that time understood that sometimes deviation can happen on the properties of elements to arrange as per their atomic weights. And another example, both gallium and germanium were unknown at that time. Mendeleev published his periodic table. He left the gap under aluminium and a gap under silicon and called these elements Eka aluminium and Eka silicon respectively. And later we know that these all elements are discovered. Mendeleev predicted not only the existence of gallium and germanium, but also described some of their general physical properties. So that type of prediction Mendeleev made in his famous periodic table. And these elements are discovered later. Some of the properties predicted by Mendeleev for these elements and those found experimentally, we put in the next table. If you see that whatever the Mendeleev predicted is the Eka aluminium, its atomic weight was predicted at that time 68, density in unit of gram per cc, it is a 5.9, melting point very low, and formula of oxides, that means E2O3, capital E letter is considered for the Eka aluminium, and formula of chloride is the ECl3. And later this element was discovered, and this naming is the gallium. That means gallium, whatever the, now we find that element, this was predicted as Eka aluminium by Mendeleev. And you can see as per the value of the different property, almost similar to the Eka aluminium, and especially for the formula of oxide and formula of chloride is same for both gallium and Eka aluminium. And another prediction by the Mendeleev is the Eka silicon, and whatever later is discovered, that element is called now the germaniums. And if you see the property, whatever the predicted property by the Mendeleev's, it is mentioned here in this vertical, in this column, and whatever already found is almost similar, and especially the formula of the oxides and formula of the chlorides is the same for both cases. And you see the Mendeleev predicted not only the existence of gallium and germanium, but also described some of their general physical properties. So physical properties I already discussed in the previous slide. These elements, later it was described, as I already mentioned, and the boldness of Mendeleev's quantitative prediction and their eventual success made him and his periodic table famous. And this Mendeleev's periodic table published in the year 1905.